In this video, we're going to talk about a complex subject matter known as resolution. And it takes quite a while before you'll truly feel comfortable with resolution, but it's actually a relatively simple concept, but it can quickly become complicated. So let's look at the basics of resolution. Here I have an image, and if you were to zoom up in Photoshop to make the image larger and larger and larger, eventually you'd realize that it's made out of little squares known as pixels. And if you were to print those pixels, they're going to be of a certain size. And if they're too big, they're going to look jaggy, like it does on my screen right now. And let's say you printed it and it looked quite like this. Well, you could hold up a ruler to the end result and isolate just one of those squares and measure how big it is. In this case, that square happens to be 1/16 of an inch. Let's just say it's part of an image that I printed on a sheet of paper. I held a ruler up and they were so big I could easily measure one of them, and it's 1/16 of an inch. Now, that's not a common way of describing how big those pixels would be. Let's look at other methods we could use. We could, instead of using a fraction, use a decimal. And if we did, we would end up with 0.0625 inches in size. Now, I don't know about you, but that doesn't sound like a very friendly number. So instead, what we usually do is we measure how many of those pixels fit in 1 inch of space on our print. And if we were to do that here, we would find that we have 16 pixels fitting in 1 inch. And that means they're quite large. Most of the time, this number is much higher. It's a number more like 300. And in order to fit 300 of these pixels in 1 inch, they have to be tiny, so you don't even see them on the printout. But all we're doing is we're describing how large are the pixels that make up our image when we print them. That's what pixels per inch, or PPI, means. Now, you will find that many people will describe this using a different term known as DPI. That stands for dots per inch. And the only problem with that is a little technicality, and that is dots can either be turned fully on or fully off. Like if you're printing with black ink, you can either put a black square on the sheet of paper or not. And if so, you're talking about dots. If, on the other hand, you can vary how much of that particular ink you're using. So instead of having it turned completely on or completely off, you could turn it on only 20% of the way or 40% of the way to vary how bright it is. Then those are not dots. You're talking about, they're probably pixels. And so when you're talking about a picture and how big the little squares that make up your picture will be when you print them, it's known as pixels per inch. But know that the majority of people out there will call it dots per inch, even though technically they're incorrect. When you talk about a printer and how small of a dot a printer can make, if it's the kind of printer that's like an inkjet, then that's called dots per inch, because it can either put the dot down or decide not to. But when it comes to your image, it's known as pixels per inch, or PPI. If you ever hear of anybody, though, describing an image as being 300 DPI, just know they mean PPI. And don't worry about it. Nobody really cares. It's just a technicality. So then, if we take this image, and let's just say we had an 8 by 10 inch image. When we printed it, it was that big. Telling somebody I have an 8 by 10 image, if it's a digital file, that's not enough information for them to know how much information is in that picture. Because that image could just as easily look like this one, where the pixels are so big, they look like you can reach out and touch them. They're almost like bathroom tiles. They're so huge. Instead, it might be a little bit more refined than that, a little smaller, or even smaller, or maybe small enough where you can't see the individual pixels. But just saying it's 8 by 10 inches is not enough information. You also need to know how many of those little pixels that make up your image fit in each inch. And that's known as the resolution, or the PPI. Although remember, a lot of people will call it DPI. So let's say we have an 8 by 10 inch image at 300 pixels per inch. That means 300 pixels will fit in each one of those inches, and it's literally that. So if you look here in the ruler, there'd be 300 pixels in the first inch and 300 in all of those other inches. And it's really simple math. You have 8 inches total times 300 pixels in each one of those inches tells you you'd have a total amount of 2,400 pixels in the width. In the height, you can do the same thing. We have 10 inches there. If we have 300 pixels per inch, that's pretty easy math. That would be 3,000 pixels in the height. So a different way of describing the exact same image is we could say either it's an 8 by 10 inch image at 300 pixels per inch. That's good. That describes what we have. Or let's say we don't know how big somebody's going to print it. We can simply say we have an image that's 2,400 by 3,000 pixels. And that's enough information to totally describe how much information we have in the file. Then we could use that and print it at whatever resolution we want, meaning you could print it huge, the size of a building, and if so, those pixels are going to get so big that you can see them, or you could print it tiny like a business card, and they'd be so small you'd never see them, but that tells you enough to tell you exactly how much information is in the file. Now there's another way of describing this, and that is if we simply do the math, multiply the width in pixels by the height in pixels, we would find out how many total pixels we have. In this case, we have 7.2 million pixels. Well, million pixels, it's actually known as megapixels. So when you hear of a digital camera having 16 megapixels, all it means is the width of the image in pixels multiplied by the height of the image in pixels. What's the total? In this case, we'd have 7.2 megapixels. Then let's look at how else we need to deal with resolution. And that is when we create a brand new file in Photoshop, it'll ask us for a resolution setting. And these are the general recommendations I would give you. You can use anything in this general range for these particular purposes. You could get away with the lower range most of the time, but the time you'd need to go for the higher range is anytime you have lines that are almost perfectly vertical, but just a littlest bit off, or almost perfectly horizontal, but just the littlest bit off. Or you have really high contrast lines, like text. That's when you want to go for the higher numbers. So that means if you have a picture of a skyscraper, you'll usually have the edges of the windows that are really close to being horizontal or vertical, and then you need to tend onto the higher sides of these. Or you have really high contrast straight lines, like the strings of a guitar or the mast of a sailboat, and it's really high contrast. The difference in brightness between that mast and the sailboat and its surroundings is huge. Then you need to go for the higher range that's here. Then the reason why you have different settings for different kinds of printing, like newspaper, magazines, inkjet, and so on, is because when you try to reproduce the various brightness levels you can see in Photoshop, each one of those kinds of printing reproduce those in different ways. For instance, this is how an inkjet printer would reproduce these same shades of gray, but using the dots. Remember, dots can either be completely on or completely off. Well, here's what I mean. They're either solid black or solid white. And to reproduce these different shades of gray, you can see how it uses more and more dots to do so. That's how an inkjet would do it. Print the same image on a printing press, though, and it would use a different technology known as a halftone to do the same thing, using, again, dots. Solid black dots on solid white paper. And so each one of those looks slightly different, and so they need slightly different settings. Now, the internet's a little different. With the internet, if you want to see how big something will look on the internet, you need to look at the top of your document, right up here, where you see a percentage. And the size this will be on the internet, which also means in an email, will only be the same as that being 100. If you see right now it says 100. The way I got to that is I double-clicked on the zoom tool. That gets me to 100% view. Let me try to scale something for the internet. With the internet, the setting called resolution is completely ignored. The resolution setting, which is the one called pixels per inch, is only used when printing. When it comes to doing things on the internet or with email, it only looks at the width and height of your images in pixels. And here's how I would change that. If I go to the image menu and choose image size, that's where I can scale my picture. And what I would do here is you can expand this dialog. Just grab the corner and pull on it. And down at the bottom, you'll find a plus and a minus symbol. Press those until you get the image to the size you'd like it to be in an email or on a website. Let's say it's this big. And then look at the number that appears down there at the bottom. Do you see mine says 44.7%? Well, if that's how big you want it to look on the internet, then set this little measurement system over here to percent. And type in what you saw down there, 44.7. So 44.7. And I don't care what this number is. It could be 1. It could be 30,000. It could be 30 billion. It's only used when printing, period. Absolutely ignored on the internet and an email. So this number does not matter whatsoever. What matters is the size the image looks when you get it to 100% view. And so now if I scale up to 100% view, it's exactly the size I was looking for. I simply click OK, and it's been scaled to that size. Now I can save it, and it'll look exactly that big on the internet or in an email. Finally, let's look at the difference between the two main areas where we deal with resolution. And that is an area called canvas size and an area called image size. First off, if we use the choice called image size, then this is how it works. When I scale an image using image size, it just makes that image larger or smaller, like this. And it means I have either a huge picture where maybe it's 5 feet wide by 3 feet tall, or I have something that's only 2 inches wide. That type of thing. But if instead I use something called canvas size. Canvas size is different. Let's see how it thinks differently. Ignore these little transformation handles that are here and just look at what happens to the image in the end. But canvas size would do the following. If I made it smaller, it would encroach into the image, cropping the image effectively. Or if I were to make it larger, the image is not going to change size. The document that contains it will change size. So if we end up making it larger, we end up with empty space around the edge of that image. That's what happens when you use canvas size. And when you're in canvas size, it will ask you, would you like to transform where your image remains in the lower right of the original or the new document? Would you like it to be centered, which would be more like this? Or would you like it to end up being in the upper left of the new larger document? And you'll find an option for that in the canvas size dialog. So know that image size means let's not change the cropping of the image. Let's simply take what we have, make it take up more space or less. Canvas size means leave the picture whatever size it was and take the document that it is within and make the document smaller so it encroaches into the picture and crops it, or make the document larger so you have empty space around that original picture, and that's how canvas size thinks. Finally, your zoom setting matters. Here I have a document where when I view it at 100% view, you can see it's a simple grid of red squares. But if I end up typing Command- to zoom out, you'll find it will occasionally look a little odd, as if certain lines within the grid are more prominent than others. And if I keep going smaller, you'll find that at certain percentages, it just doesn't quite look right. And it's only if I get to 100% view or higher that it always looks right. It always looks like a grid of red. It's when you go below 100% that on occasion you're not seeing an accurate view of your picture. The reason I bring that up is sometimes you open a picture, let's say it's a panorama you just finished stitching, and it looks odd. Where one picture should blend into the other, it looks like there's a weird transition between the two, almost like there's a little worm going between it. If you see that, zoom up to 100% view or higher to make sure you still see it. And if you don't, it means it's just an oddity of trying to visualize too much information on a screen that just doesn't have enough little bitty pixels within it to display that much detail. And so anytime you're below 100% view, it might not look quite accurate. So that should give you some clue about resolution. There's a lot more to learn about it, but it really is simple. It either means the width and height of your image in pixels. That's enough to describe how much information is in the file. Or if you prefer inches, tell me the width and height in inches, but be sure to include the pixels per inch so I know how much information fits in each one of those inches.